8th graders, we're going to start a brand new section. We're going to do a couple examples out of 8.3, and we're going to graph quadratic functions. And so we're getting a little bit more difficult with our graphing. Now we have a full-fledged trinomial that we want to graph, and I want to help you do that today. So first thing I want to ask you is, does our parabola open up or down? Now hopefully you said, oh, it opens up. The reason is because A is 1. And because A is a positive number, that means our parabola is going to open up. So it's very helpful that we know the shape and anticipate how it should look before we actually graph it. Now we're going to calculate some other things because as we're planning our graph, we need some data so we know, do I need a lot of first quadrant? Do I need a lot of fourth quadrant? Is there a quadrant I need to focus in on? We need these numbers to kind of drive that activity. All right, the second thing we want to do is calculate our axis of symmetry. Now remember, our axis of symmetry is a vertical line, and we calculate it using negative b over 2a. Well, in our problem, a is positive 1. It's an understood 1, while b is a negative 4. So when we plug into the negative b over 2a, we want to take the opposite. That's what that negative sign right here is. Take the opposite of whatever b is. Well, if b is a negative number, the opposite of a negative number is a positive number. So we need to write a positive 4 there. And then 2 times a, 2 times 1 is 2. 4 divided by 2 is 2. So here's our axis of symmetry. It's going to be a vertical line through positive 2 on the x-axis, okay? Now, our vertex is really simple. We already know what x is, so to find y, we're going to take the 2 that we just calculated and plug it in everywhere we see an x, okay? You can actually plug 2 squared minus 4 times 2 minus 5 into your calculator right this second, and you're going to figure out that the missing value is negative 9. So your vertex is going to be 2, which is your x. We already knew that. We calculated our axis of symmetry. The axis of symmetry, that number is the same number as the x of your vertex. And then we just calculated the y. So it's going to crisscross at 2, negative 9. And then if you want to find the y-intercept, it's very simple. Just plug in 0 for the x. So we have 0 squared minus 4 times 0 minus 5. Okay, now just logic says 0 squared is 0, 4 times 0 is 0. What's left? Negative 5. And so our y-intercept is going to be 0, negative 5. So there you go. We have some very, very important data. We'll find more points a little bit later. Hold on to your hats. We're going to do that a little bit later, okay? So as you can see, our vertex, really kind of focus in on this point. That's going to be pretty deep in the fourth quadrant because we're going to move positive 2 on the x and then down negative 9 on the y. That's going to be a very, very deep fourth quadrant. So what we're going to do when we draw this, let's go ahead and kind of draw it very bottom heavy. We see a lot of the third and fourth quadrants and mainly fourth. And let's start with the very first point that we know. Let's graph our vertex. Let's go to 2 on the x and then count down 1, 2, 3, 4, 5, 6, 7, 8. And there's negative 9. There's your vertex. That's the very bottom of your graph because from that vertex, the parabola is going to open upward from that vertex. So it's very important that we know that. Now the vertex is marked, so I'll put a little check mark there, dealt with that. I do want to draw a vertical dashed line that's identifying the very center of my graph. So there's my axis of symmetry there. That's the very center of the graph. Okay, so that's done. I marked that. And then I'm going to also mark my y-intercept, which is 0, negative 5. Beautiful. And that's my y-intercept. Okay, so normally on this type of graph, I would like to see 5 points on a parabola, just as a teacher. It shows trend, and we want to be very deliberate in what we show. So I already know 0, -5, and I know 2, -9. What I didn't know is, what if I plugged in a +1 for my x? So I'm going to make a little XY chart, and I'm going to plug in +1. Now what is that going to look like? Well, I'm going to do 1 squared minus 4 times 1 minus 5. You can put that right into your calculator or do a little bit of quick mental math, and you will find that when I plug in a +1, I'm going to get -8. And so I'm going to count down. Here's +1. I'm going to go down to -8. 1, 2, 3, 4, 5, 6, 7, and here's 1, -8. And that's really the only calculated point, the only one I have to plug in, because that I can find the other two without calculating. It's really neat. I'm going to show you a quick trick, and it's called reflecting. Okay? The concept, we know that a parabola has symmetry to it. Okay? We know it has symmetry to it. So whatever's on the left side of the parabola is reflected on the right. So if I fold it right along that axis of symmetry, where would the y-intercept touch on the other side? Let me show you how to figure that out. Okay? Notice, and it has everything to do with the axis of symmetry. How far away is the y-intercept from the axis of symmetry? Do you see where I moved it to? It's 2 places over. Well, to reflect it on the other side, we're going to move it 2 places over, and there it is. Okay? Do the same thing with our calculated point, 1, -8. It's 1 unit from the midline, so we're going to move it 1 unit away. And there you go. Look, we have 5 points, and I only actually had to calculate on an XY table just one of them. The vertex I calculated a little bit differently, and the y-intercept I calculated a little bit differently. So if I let me get some of my marks out of here. I didn't mean to draw these arrows. I just wanted to show you how to reflect. So if I kind of clean this up just a little bit, you can leave your arrows there. For some reason it bothers me. And I'm going to connect my points now with a smooth curved line, and there's your parabola. Looks great, and that's how you do it. Okay, so those are the basic steps. Now I'm going to help you on the next page, and then I'll give you a hint on the next one. Okay, so first thing, does it open up or down? Well, A is 2, so A is positive. That means it's going to open up. Now we need to calculate the axis of symmetry. In order to do that, I have to take A, which is 2, and B, which is 6, and plug it into this very simple formula, the opposite of B over 2A. Well, the opposite of 6 is -6, and 2 times 2 is 4. And -6 divided by 4 is -1.5. Okay, so that's going to be, this is my vertical line, and if you are under the mistaken impression that our answers always have to be integer, I'm going to dispel that myth right now. These numbers can also be decimals, and as clearly indicated by our calculation. So let's go down to our vertex. We already know that x is -1.5. So to find the y, you're going to carefully plug in, and I would use parentheses here as you're plugging it into your calculator. I'm going to write it just like you should type it. Okay? Just trying to help you guys out a little bit so we don't mess up any calculations. All right, so we want to multiply 2 times the square of -1.5, then add 6 times -1.5, and then add 2. Your calculator will do all of that for you, and you should have gotten as your y -2.5. Okay? And then our y-intercept, very simply, in order to find your y, you're just going to zero out your x's. So we got 2 times 0 squared plus 6 times 0 plus 2. Remember, anything times 0 is 0. So those are gone, you're left with 2, so your y-intercept's going to occur at 0, 2. Okay, so as you're looking at your numbers, really we need some third quadrant action because we have a negative x and a negative y for our vertex. So let's kind of, as we're drawing this, let's go about that depth on our graph, and I'm going to make it kind of heavy on that third quadrant side, just like this, okay? So we're going to get it going that way. And let me do a little bit of erasing. You don't erase, let me erase so I can have some room down here, okay? Alrighty. Looking good. Alright, thank you for your patience. I really appreciate that. Okay, I just want to draw a little bit tighter here. Okay, so the first thing I want to graph is the very bottom point of my parabola that's opening up, and that's -1.5, -2.5. So if I start here and I go, here's -1 and here's halfway. So I'm going halfway between -1 and -2. And then I'm going to go down 2.5. And there's my vertex right smack dab in the middle of the box. It's not even on a grid intersection. And that's okay. It doesn't have to be. Okay? Let's go ahead and we're going to draw that vertical line straight up, right halfway between that -1 and -2 on the x. Okay, so there's our axis of symmetry. We know it's going to open up, so that's looking good. And then we know the y-intercept is at 0, 2. Okay? Oh, sorry, I drew that wrong. I did 0, -2. Excuse my B. No wonder that looks so weird to me. All right, so 0, 2. There's our y-intercept. Okay, so what we want to do, we know here's 0, 2, and we know -1.5. Let's plug in a -1. You see where my pencil tip is right here. I don't know what the corresponding y is to that, so we're going to do our xy table, and we're going to just plug in a -1. So that then will reflect our 2 points that we know. So what you'll need to do in your calculator is this: 2 times -1 squared plus 6 times -1 plus 2. So I'm writing it just like you should be plugging it in. Okay? Put parentheses around that -1, especially when you're squaring it. If you don't, then the calculator is going to think you're not wanting to square a -1, but just rather a 1. Okay, now I just calculated it and I got exactly -2. So let's graph that. -1, -2, and that's where it is. And that's my only calculated point. The rest of it, I can reflect the other two. Okay, so let's start with the y-intercept. Now notice we are 1.5 units away. So we're going to go 1/2 and a 1 away. That's 1.5. Okay, just like that. So if my one point is 1.5 units away on the right, then my other point on the same level, okay, same height on the y-axis, is also going to be the same distance away from that midline. Okay, and notice my -1, -2 point is only 1/2 a unit away from the midline. So go 1/2 a unit to the other side and mark it. And this is what your parabola should look like. Okay, so I'm really hoping I'm landing this plane and getting you to see how to do a reflection. So you don't have to do too much calculating, just a little bit to get this going. So 3 points we calculate and 2 we reflect, and you got it. There's your 5 points, okay? So the next one, this one's all for you. What you need to do is, first thing to get this started, get y by itself, okay? So right now, you've got 6x over there. You have got to move that 6x over to the other side so that y is by itself. And then you can finish the problem the rest of the way. So these are the types of things that I want to see. Does it open up or down? Okay, which one does it do? What's the axis of symmetry? What's the vertex? What's the y-intercept? And then last but not least, I want you to graph it for me and then show me the reflected points after you need to calculate, I think, 1 point. It'll end up being 1 point and then reflect 2 of them. Okay? So this one's for you. Because this is so labor intensive, I'm feeling so generous. I'm going to give let's see, I think I'm going to give 1 point for every correct thing. So 1, 2, 3, 4, how about 5 points total, including the graph, if you can show me all of this data on your paper. Okay, so bring this to class tomorrow. Let me help you if you just clearly don't understand.